Okay, so let's see how we did and the rest of them. Hydrogen has, it's an element, atomic number is 1, has 1 proton, 1 electron, 1 in the outer shell. It only has 1, right? Now it's tricky because it's not how many more does it need to get 8, it's how many more does it need to get to 2, right? Yeah, I know. Some of you might, so it needs 1 more, because remember, that's the one exception to our wonderful rule. Okay? So it can bond 1 more time. Phosphorus, what's phosphorus number? What is it? 15 on the periodic table. It has 15 protons. Therefore, it has 15 electrons. So if we put 2 in the outer shell, and then we do 5 more in the next level, or I'm sorry, 8 more in the next level, there's 5 left over, so that means it has 5, right? What family is it in? 5. So what you're telling me is the number of valence electrons also tells me the family I'm in, okay? How many more to get to 8? 3, so it can bond 3 times, okay? Oxygen, what's oxygen's number? 8, right? How many number of protons does it have? 8. Electrons? 2 on the inside. How many are left over? 6. How many more times to get to 8? 2. What family is it in? 6. Okay. Sulfur. Atomic number of sulfur? 16. Okay. Number of protons is 16. Electrons is 16, right? Protons equal electrons. Number of valence electrons, 2 on the inside, 8 in the next one. That gets us up to 10. 6 more, right? So it's 6. Hey, is oxygen and sulfur in the same family? I think oxygen's right underneath it, right? So they're both in the same family. They both want to bond twice. Okay? Nitrogen. What's nitrogen's atomic number? 7, I heard. Number of protons is 7. Electrons is 7. Valence electrons in the outside. I've got 2 on the inside. How many are left over then? 5. So I go 5. On the outside, it's in family 5. Who else is in family 5? Phosphorus. So phosphorus and nitrogen are in a similar family. Okay? Those are both fertilizers, by the way. That might mean something. So 5. How many more to get to 8? 3. Okay? All right. Not terribly difficult. So I want you to go ahead and divide this area here up into 4 parts. Sorry. The first part is going to be the atomic model. The next part is going to be Lewis dot. The next part will be the structural formula. The last part will be the chemical formula. All right. Atomic model. The atomic model shows what the atom would look like. So we have to show the electron levels, all that stuff. So we start off. It's saying you need to bond hydrogen to hydrogen. These problems will never tell you how many of each we need. You'll have to figure that out. So hydrogen to at least 1 more hydrogen, we know that. And if we start, I should say, with that outside level, we know that each has how many in its outer shell? And we know that if they share that, they both feel like they have 2, right? Okay. So that's the atomic model. Are they both happy now? Yeah. The Lewis dot. We don't draw the circles anymore, but everything else remains the same with the outside. We only show the valence level. That means if I had 10 levels, I wouldn't care. I would only look at the last level when I drew the Lewis dot structure. And I, of course, circle that shared pair. And in the structural formula, anytime you have a circled shared pair, you draw a line. What if I had 2 shared pairs? I'd need what? 2 lines. But hydrogen can only bond once, right? So you told me up here in our chart. Last one is the chemical formula. How many hydrogens are there? 2, right? Pretty simple. Let's do the next one. Next one, same deal, guys. Okay? Hydrogen to oxygen. Do you know how many of each I need? I don't. Always do hydrogen last. Who do you do last? Hydrogen. So we have oxygen. Let's do oxygen first, okay? How many electrons does oxygen have? 8. Inside level holds how many? Next one holds how many? 6. 1, 2, 3, 4, 5, 6. Folks, I don't care where you put these electrons as long as you put them in pairs when they can be in pairs. I don't care about the perfect way to put them on. That doesn't bother me, okay? But what you do need to do is make sure all bonding is fulfilled when we do these. So we're going to start with one hydrogen. Let's see what happens. Hydrogen has how many electrons? 1. So this hydrogen is going to bond here. Is that hydrogen now happy? Yes. Can it bond again? No. So let's look at oxygen. Oxygen now has 2, 4, 6, 7. Is oxygen happy? No. You look at your chart. How many times does oxygen want to bond? Twice. So we're going to need another hydrogen, right? So if I do another hydrogen here, and I circle another shared pair, this other hydrogen is happy now. Now I have 2 bonded hydrogens, both of them happy, and oxygen now has a full outer shell. It's happy, right? What molecule is that? It's water, right? H2O. Okay. So the next one, let's make it simple. What family is oxygen in? 6 family, so that means it has 6 valence electrons, right? See how you can do that real simple with the Lewis dot? It's in the 6th family, it has 6 electrons in the outer shell. And we know we're going to need 2 hydrogens, right? There's one. And there's one. Now you can do this a different way. You know, a lot of people do this. Let me just show you what a lot of people do. They say, well, now this oxygen has 8, right? And this hydrogen has 2, and this hydrogen has 2. Anybody done it that way in the past? Yeah, that's okay too. But all that's showing me is that now oxygen has 8 and hydrogen has 2. But if that gets confusing, which it does a little bit for me when I'm trying to just understand what's going on conceptually, I like to just leave it like that, okay? Just because it kind of like takes a step back and we say, okay, now we don't have these lines all over everything, okay? And it's saying the same thing. Next one. How about we just show those shared pairs with one line? That's pretty simple, right? Anytime there's a circle, you draw a line. And then in the last one, of course, this is our solvent of life, H2O, chemical formula. All right. Now, flip that over to the back side, and I'm going to give you a little bit of time to work on the next 4. First showing me the atomic, then the Lewis dot, then the structural, and then finally the chemical formula.